In this question, we are told that there are two non-negative numbers whose sum is 9, and the product of one number and the square of the other number is the maximum. And we're asked to find the smaller number and the larger number. Let the two non-negative numbers be x and y. In making use of the first information, sum is 9, we have x plus y to be equals to 9. So making y as the subject, we have y is equals to 9 minus x. Product of one number and the square of the other number is a maximum. Let the product to be p, the number with the square term be x squared, and the other number, let it be y. Y is equals to 9 minus x. If we expand it out, we will get 9x squared minus x cubed. The derivative dp dx is equals to 18x minus 3x squared. Since at the maximum point, which is also a stationary point, dp dx is equals to 0. So 18x minus 3x squared is equals to 0. Let's take out the common factor x. It means that x is equals to 0, or 18 minus 3x is equals to 0. X is equals to 6. Y will be 9 minus 0 equals to 9. When x is equals to 6, y will be equals to 9 minus 6 equals to 3. So here we have two possible values of x and y. Let's check which one gives us the product p as a maximum. We can use the first derivative test to tell us which is the correct x and y that we're looking for. For the first derivative test, let's test points that are close to these two stationary points, 0, 9 and 6, 3. At x equals to 0, we know that it is a stationary point. dp dx is equals to 0, so that's 0 slope. When x is actually equals to negative 1, let's look at the behavior of the slope. So we realize that dp dx is equals to 18 multiplied by negative 1 minus negative 1 squared equals to negative 21, and this is smaller than 0. So let's put this as dp dx. At x equals to negative 1, dp dx is negative, so we have a negative slope. So we can draw a slope that's coming down. So let's test points that are on the right of the stationary point 0. So when x is equals to 1, dp dx will be equals to 15, and this is bigger than 0. So it's a positive slope. So we have a slope that is going up. So we can see that at 0, 9, this is actually a minimum point. Let's verify whether the other stationary point, 6, 3, is actually a maximum point. So at 6, 3, this is x. So at 6, it is a stationary point, and dp dx is equals to 0. So that's 0 slope. Let's test points close to the stationary point. When x is equals to 5, dp dx is equals to 18 multiplied by 5 minus 3, 5 squared. Note here we are making use of the formula dp dx that we have found earlier. This value is a value that is 15, so it's bigger than 0. We have a slope that is going up. Next, let's test the other point at x equals to 7 on the right of the stationary point. dp dx, the slope of product, is actually equals to 18 multiplied by 7 minus 3, 7 squared. This is equals to negative 21, which is less than 0. It's a slope that is negative. By first derivative test, 6, 3 is a maximum point. 6 and 3 are the two non-negative numbers that we are looking for. Hence, the smaller number is 3 and the bigger number is 6.